Welcome back, students. In the last session, we had discussed that a current carrying conductor in a magnetic field experiences a force. In this module, we are going to study the factors on which this force acting on a current carrying conductor in a magnetic field depends. Students, the force depends on four main factors, and these are strength of the magnetic field, current flowing through the conductor, length of the conductor, and the angle between the conductor and the magnetic field. The force acting on the current carrying conductor is directly proportional to the strength of the magnetic field. जितनी स्ट्रॉन्गर मैग्नेटिक फील्ड में आप उस करंट कैरिंग कंडक्टर को रखेंगे उतनी ज़्यादा फोर्स उसके ऊपर लगेगी. It is also directly proportional to the current flowing through the conductor. The force is also directly proportional to length of the conductor. That means longer the conductor, greater will be the force. It also depends on the orientation or the angle between the conductor and the magnetic field. Suppose this is your current carrying conductor, its length is L and current flowing through it is I. Let theta be the angle between this current carrying conductor and the magnetic field. So the force acting on this current carrying conductor will be given by the expression F is equal to ILB sine theta, where F is the force acting on the conductor, I is the current, L is the length of the conductor, B is the strength of the magnetic field, and theta is the angle that the conductor makes with the magnetic field. So F is equal to ILB sine theta is an expression by which we can calculate the force which the current carrying conductor in a magnetic field will experience. Now let's see when is this force acting on the current carrying conductor maximum and when it is minimum. We have learnt just now that F is given by the expression ILB sine theta. So for force to be minimum, the value of sine theta must be minimum, and the minimum value of sine theta is 0. You must have learned this in your trigonometry chapter in mathematics. And for sine theta to be 0, theta must be equal to 0 or 180 degree. That means when the linear conductor which is carrying current is parallel or anti-parallel to the direction of magnetic field, then the force acting on the current carrying conductor will be minimum, that is 0. जब वो parallel direction में या anti-parallel direction में होगा with the magnetic field, then it will experience no force. Right, students? Force will be minimum, that is 0. And for maximum force, the value of sine theta must be maximum, and the maximum value of sine theta is 1, which is possible when theta is 90 degree. So if I keep my current carrying conductor perpendicular to the direction of magnetic field, it will experience maximum force. So for minimum force, it should be kept parallel or anti-parallel to the direction of magnetic field, and for minimum force, it should be kept parallel or anti-parallel to the direction of magnetic field, and for maximum, it should be kept perpendicular. So far we have studied that a current carrying conductor in a magnetic field experiences a force, and we have also studied the factors on which the magnitude of this force depends. Now let's see how we are going to find the direction of this force. A simple rule which is known as Fleming's left hand rule can easily help us to find the direction of force. Let's see what the rule says. According to this rule, stretch your thumb, forefinger and middle finger of your left hand such that they are mutually perpendicular. If the first finger points in the direction of magnetic field and the second finger in the direction of current, then the thumb will point in the direction of motion or the force acting on the conductor. What does this mean? Let us try to understand this with the help of this sketch. Here you can see that the thumb, the forefinger and the middle finger of your left hand are stretched so that they are mutually perpendicular. आपस में ये तीनों perpendicular हैं. If they are stretched mutually perpendicular to each other, then if your forefinger points in the direction of current and your middle finger points in the forefinger points in the direction of magnetic field and the middle finger points in the direction of current, then your thumb will point in the direction of force or the motion of the conductor. अगर आपका थंब, फोरफिंगर, मिडिल फिंगर आपस में म्यूचुअली परपेंडिकुलर है एंड आपकी अगर फोरफिंगर मैग्नेटिक फील्ड की डायरेक्शन में पॉइंट कर रही है, मिडिल फिंगर करंट की डायरेक्शन में पॉइंट कर रही है, तो आपका थंब जिस डायरेक्शन में पॉइंट करेगा दैट विल बी द डायरेक्शन ऑफ फोर्स और द मोशन ऑफ द कंडक्टर. Let us try to solve a problem based on this rule. This is actually problem 13.2 of your NCERT book. The question says, an electron enters a magnetic field at right angle to it, as shown. The direction of force acting on the electron will be to the right, to the left, out of the page, into the page. According to question, this is the direction of magnetic field and this is the direction of electron. The electron is entering the magnetic field at right angle. आपको force की direction find करनी है. Students, in electricity chapter we have learned that the conventional direction of current is opposite to the flow of electrons. So अगर this is the direction of electron, then the current will flow in opposite direction. Right students? अगर electrons इस तरफ आ रहे हैं तो current will flow in the opposite direction. Now apply Fleming's left hand rule. Stretch your thumb, forefinger and middle finger of your left hand and such that your forefinger is pointing in the direction of magnetic field, your middle finger points in the direction of current, and the direction in which your thumb points gives us the direction of force. So applying this rule, we can find the direction of force, that is into the page. Right students? So this was all about the force acting on a current carrying conductor in a magnetic field.